DDB is a distributed debugger, which enables interactive debugging on distributed applications. Before we jump into DDB, let's first take a look at the status quo. So nowadays, interactive debugging on distributed applications is actually quite hard. First of all, it's really hard to manage all the process. Distributed applications usually consist of many distributed processes across different nodes. To enable interactive debugging in this setting, the developer has to manually attach all the GDB sessions to all these different processes. And to perform some operations, developer has to jump between different GDB sessions, do operations like insert breakpoints, view the local variable, do the backtrace. It's also really hard to view the distributed states in this setting. Let's say the developer trying to view the local variables from different process. The developer have to first figure out the GDB session. Then it goes to that GDB session to locate the exactly frame. Then you perform the local variable read. After that, developer has to switch to a different GDB session and repeat the same procedure. And this adds a lot of cognitive overhead to a developer. Let's consider about a different case. Here, let's say one process trying to send the RPC to another process. So essentially here, there's a caller trying to contact callee through the RPC request. And now let's say the developer trying to understand the behavior of the both callee and the caller, trying to understand how things flow from the caller to the callee and what kind of operation they're doing. To do that, one might have to do the backtrace. However, backtrace doesn't really work well in this case. GD backtrace stops at RPC boundary. So developer has to first do the backtrace on the callee side. Then developer have to go figure out who's the caller, then jump to the caller GDB session, then locate the correct sender thread, and perform the backtrace on the caller side. After all this, developers still have to manually form the mental model of the entire call stack from both callee and the caller side. So this is really inconvenient. It also have lots of disrupting side effects. For example, again, here, the caller trying to contact callee through the RPC. Let's say the developer trying to understand the issue with the callee. So it paused the execution of the callee for a couple of minutes. So the developer can actually view all these unstacked variables and examine all the heap data on the callee side. However, during this time, the caller can just say, okay, I'm waiting for the callee for quite some time. And the callee is not responding, so the caller might just consider the callee dead. So you're gonna just time out and exit. When this happens, developer cannot go back to the intended debugging flow. So the debugging flow is actually broken. This creates much disrupting side effects and makes the interactive debugging on distributed systems almost like impossible. Now, DDB aims to address all these problems. It provides a unified view where you can view all the process and all the distributed states from a single unified interface. And it can also provide the distributed backtrace, which can backtrace across opposite boundary. It can also suppress pause-induced timeouts to make sure your debugging flow won't be interrupted or disrupted by such unintended timeouts. We got much more to offer. So let's try DDB and start experiencing interactive debugging on distributed applications. In the following videos, I'm gonna cover some basics and also some advanced stuff on DDB. Stay tuned.